Well, congratulations, folks. We've gone from basic Python to using Python. And this is one of the fun things. Let's talk about how to do graphics. Now, there could be good arguments why matplotlib is not the first choice of routines that you would use to look at for plotting in Python. I happen to think it's a good place to start. It's effectively the only thing that I use, although I'm aware of other stuff. So let's see. Oh, I forgot to write an outline. That's cute. Oops. All right. Well, let's talk about creating graphics. One of the nice things about Python is that you can create high-level graphics stuff, and when I mean high-level graphics, graphics that you'll be happy to see on your screen, but also graphics that you'd be happy to put into a paper, and with a small number of calls, quite easily. The graphics library matplotlib is very good for this, but there's a number of other packages. The one package called Chaco is also very good, and the folks at Enthought tend to prefer Chaco if you're going to be writing code that you're going to do graphics in, as opposed to matplotlib was sort of written for people who were trying to do, originally was written for people trying to do MATLAB type graphics. Calculate something, plot it. Calculate something new, plot it. So you were doing it more interactively. But it works very well for both. It just takes a little bit, it just gets a little bit confusing. So if you want to learn about matplotlib, a great place to go is the web page for it. There's a 1,000-page manual you can download on matplotlib. There's also a book which I have looked at a little bit and I've used a little bit from. It's a pretty easy to use, easy to read book, and it's on Safari for anybody who has a Safari subscription. Another nice thing about matplotlib is this gallery, and I've just got a little section of it. This is probably somewhere between 1/4 and 1/10 of the gallery. And if you click on any one of these plots, you'll see the code that generated it. And these examples are typically 10 lines to a couple hundred lines at most. And most of them are probably under 100 lines of code. So you can generate some really pretty sophisticated graphics with really pretty minimal code. Okay, now I'm going to tell you from the top that I find matplotlib a little hard to follow, particularly when I start looking at other people's examples, because it was written to be used in, it says here 3 ways, but I've got 4. Quality control in this talk is lacking. Okay, it's meant to be used interactively. I'll show you how you do that. It's meant to be used for standalone graphics with one window for all the plotting. It's meant to be used as well with object-oriented plotting. And then finally, you may want to use matplotlib with a GUI in some fashion. And I'm not going to talk about that today, but because I don't really see much point in that until you've at least seen a little bit of WXPython. So for interactive use, there's more than one way to do this, but using the IPython shell is the way that makes the most sense. For simple scripting, when you do it in the IPython shell, you use a module called Pylab. Pylab is both matplotlib and it's NumPy, and I think even some of SciPy. If you're going to do simple scripting, you'll use the pyplot subpackage of matplotlib, and that makes things easy. However, if you want to use the most sophisticated level of matplotlib, you'll do things with object-oriented scripting. And that's what you'll need if you, for example, want to use GUI routines and stuff like that. And I'll try to give you a little bit of feeling for all of these, starting with the simplest. So simplest example is using IPython. If you say ipython.pylab, it causes matplotlib.pylab and numpy to be imported. Unfortunately, it does that with an import star for you. So this is a numpy routine, and it works now without the numpy prefix. Okay, I believe you can still use the numpy prefix anyway, and I'd recommend you get used to that. You certainly could have name collisions if you do an import star. The most recent thing that you imported is the one you get. So, so this is an example that I actually showed you before, where I compute a Bessel function, and this is a numpy routine. This is a numpy routine. This is a numpy routine. And now I'm pulling in something that I didn't get by default, which is the special routines in SciPy. So I have to import that directly, and you'll see now I have to use the name for that. Okay, so there I do that, and then finally I just simply say plot it, and this is a bunch of different curves, and I get all the curves plotted for myself. So it's plotted each row in the array. And because I use Pylab, I don't even have to tell the computer to update the screen. It automatically does that for us. Probably not the way I wanted to plot things. If I do it as a contour plot, here I clear the screen, and now I ask to plot this thing as a contour plot, and now I see the same information plotted as a 2D array. Okay. I mention this for a couple reasons. One of which, it's not a bad way to develop code. Second of all, if you're used to working in an environment like MATLAB, you can see that this works very similar. You can do the same sorts of things. Some stuff is the same. Some stuff has changed a little bit. There's even a guide out there for MATLAB users and maybe even for Mathematica users on how to work with Matplotlib and NumPy and SciPy. But the advantage is that you're halfway towards developing code when you do it in IPython. And it's quick and it's easy, and it's certainly a good way to think about developing mathematics. Okay. If you want to do stuff in scripts, though, you probably want to do it a little differently. I would not recommend that you use Pylab if you're going to write a script. So here's the same plot, but now done as a script. So I pull in scipy.special, I pull in numpy, and I'm going to abbreviate it as NP, and I'm going to pull in the pyplot part of Matplotlib, and because I don't like typing that much either, I abbreviate it as PLT. So here I compute my grid. Here I take the square root of that. Here I compute the Bessel function, and then here finally I plot it. And now, because I am doing this in a script, I have to tell the computer specifically, show the graph. If I don't tell it to show the graph, what will happen is it will run through this entire thing, and it'll print done, and it'll delete the graph before I ever can see it. So this is what tells it, put it up and let me see it. Okay. But if you do this, you'll find that this print statement never happens while this is being displayed, because it stops and waits at this point. And these things are really nice. This allows me to move the image around. This allows me to zoom in. This allows me to export it to a disk file at quite high resolution. But if I want things to happen more sophisticated, where I do plotting and then something else happens and buttons and widgets and all sorts of things can take place, then I need to do more sophisticated level of graphics. So for example, let's say I want to run a scan program on my diffractometer and have it plot and run and plot and run, and it's going to run independently. Then to do that sort of thing, I can't just do a plot show, because the whole show stops at that point. At that point, one needs to start thinking about using doing the object level code with Matplotlib. So you need to understand more about objects perhaps than I've really explained to you yet. But first thing I should explain is that the highest level thing that Matplotlib works with is called a canvas. The canvas has actually got to be implemented in some other package. In this case, what we're working with is WXPython, but it can be, there's at least 2 or 3 other different routines that will create canvases for us if we need them. Then we create a figure inside the canvas, and the figure is where we do the drawing. Then finally we create axes. We may want to have more than one set of axes in our figure. Those axes could be superimposed, or they could be multiple. We could break up the figure into 4 plots, for example. Then we do some sort of plotting in the axes, and then finally we show everything. Okay, so this does the same thing, and actually, in this case, yeah. I don't know if I need. Yeah, in this case, I'm still using pyplot here, but now I'm doing it in an object-oriented fashion. Okay, so this is sort of a mixed level of usage. And here I'm doing things a little bit more complicated. I'm creating 2 subplots. This is the first set of axes, this is the second set of axes, and I'm plotting the same information 2 different ways. So that gives you an example of something that I would have that would be that I can do more easily with Matplotlib when I'm starting to work with it as objects. Okay. Once I start using the objects, I can start modifying things. So going back to some code I used before, when I do the contouring, it creates an object for me. The object is this representation here, and as I did before, I created axes. I can start modifying them. So here, rather than using the default color mapping, I've switched to a different color mapping, so I can display it in a grayscale. And I've now labeled the axes as well by putting some modification. And finally, I've modified the figure by asking it to display a color bar for my contour map. So it gives you a feeling for how you start doing more and more stuff with Matplotlib. I will tell you that you're going to end up looking at the documentation. It's unavoidable. I can't tell you everything you need to know about Matplotlib. But as I said, there's a really nice gallery of stuff to work against. Okay. But not all the graphics you want to do is going to go on the screen. How do I do graphics that's going to go into a file? Well, this gets a little bit tricky, but the first thing you do is you import Matplotlib, but before you use it, you tell it to use a different output device. And honestly, I don't remember what AGG stands for, but I know that it means not on the screen. Okay, this is code you could use when you're running a batch job in some fashion that doesn't actually have a screen to talk to. So now I can start using Matplotlib, and when I'm done, I can say save fig, and in this case I've asked it for a PNG file, portable network graphics, a bitmap file, and there's the bitmap file. And if I want to, I could specify the density that it's going to use in terms of make it 1,000 by 1,000 bit PNG file if that's what I want. So the same code you can write that will display stuff on your screen will give you nice bitmap graphics or other types of graphics. I do not remember all the different types of export formats, but I believe it'll give you PDF and PostScript as well. You can plot in multiple windows. So here's some code where I've told it to create figure, and then when I use a new figure, if I call it figure again and I give it a different number, it says this must be figure 1, this must be figure 2, and so it's created 2 graphic windows for me. So here I'm showing the same information one time in grayscale and with a what do you call it? A color bar to give me a label, and the other time I just did it as I did before. Okay. What else? Okay, let's go back to that module that I was talking about before. Okay, with where I was talking about the tabbed window module. So that's done in this plot notebook file. Okay, and as I mentioned before, the routines in there automatically initializes things. It provides a function, 2 functions. It provides one called make plot window and another one called show plots. And as I tell you right here, show plots is the last thing that we do. So let's look at how this works. Okay, so here's a demo using that module. Okay, so first thing I do is import it, and then I say create a window for me with make plot window. Then I add a tab to that window, and then I'm going to do some graphics in that tab. All right, then I create another tab, and I'm going to put some more graphics into that tab. The graphics here, in the first tab, I'm plotting 0 to 9 against 0 to 9. And in the second tab, I compute the square of that, and I plot 0 to 9 against those values squared. So 0 to 81. And then finally, the last thing I do is I tell it to show the plots. So let's see what the output from that is. Okay, when I just run it, I get this. Okay, but notice something that you didn't see before, other than the fact that now my manipulation stuff is down here. I get 2 tabs. Okay, and by default, since I haven't told it otherwise, it shows me the first tab, and you can see now why I plotted it twice. The first time it plots the blue circles, second time it draws the red line. Now if I click over here on the plot 2 tab, I see the second plot, and now I see the plot of the squares. So this is something that's actually rather annoying to do if you have to do it in your own code to set up all those tabs and stuff and figure out how to do it. But I've done it for you. You don't need to know how to do it. That's the nice thing about a module, is you don't have to understand it. Now, I can't really explain how everything in that module works because we haven't talked enough about matplotlib. I'm sorry, we haven't know about WXPython to explain the WXPython parts of that module, but I'd like to take you through it a little bit. So let's see what's actually happening. There's 4 parts to that module. The first one is that it imports a bunch of stuff. You don't necessarily even need to worry about what stuff it imports, other than to make sure that you've got all the stuff that it needs. Because if you don't have the packages I'm calling, it's not going to work. But Python will tell you that. Second thing is it does some initialization. So you can see these lines here, they are running something. So first thing it does is it creates a WX Python application for us. Do you need to understand what that does? No, because it just does it for you. And it sets up a variable, frame list, which it sets to be an empty list. That's our initialization code. So that's going to get done when we import the package. I've simplified make plot window a little bit to take out some stuff that we haven't gotten to in Python that you don't need to know about. But basically, all it's going to do is call when we call this routine, has a default size which we can override, and it calls something that's also defined in an object. It calls plot notebook, which is a class that's defined, which I'm not going to explain. It accesses the global variable frame list, and it saves this into our list as well as returning it. So it creates something which I'm calling a plotter, which is our plot notebook. It's our window, and it saves a reference to that. Okay, that's fine. What else does it do? Well, when I call show plots, it's going to go through my list of stuff that I put in my frame list, and it's going to call show on every single one of those for me, so I didn't have to keep track of what I created. And then finally, it's going to do what's called starting the event loop. It's going to put us into WXPython and say, okay, now start looking for WXPython buttons. Again, you don't have to know what it does because it's wrapped inside a module for us. And you saw a demo of how it works. And let me just show you the code in a little bit more depth. Let's see if I can find it. Oh, here it is, right here. Terrific. Okay, so there's more. There's more documentation here. You can see I've put a nice big long doc string at the top explaining what it's does and its use. Let's see. Somewhere I read that it may be a good idea to define a summary in the first line, so I haven't done that. Then I import a bunch of stuff. That's the imports. Then immediately down below here you can see that I have some initialization code. Exactly what I showed you before. Then here's the make plot window code, which has a little bit more stuff in it, but mostly it's documentation. Explains what the input and the output's going to be. And then we have the show plots, which is exactly what I had before. And then what I don't want to get into now is the guts, which are done by defining objects with a class for the notebook, and then finally a class for the tab, and a few different routines you can use with tabs. But what I do want to point out is that I put in some test code here. And I show, with this test code, I define a couple routines that I'm going to use, and have some demonstration code. So this does a lot more than what I showed you in the first demo, but let me just show it to you. Let's see, it's here. If I call it, well, actually, let's just show you a quick demo that uses it. Here's the routine that I just showed you before. So we can run that, and like so. So let's run the demo routine that imports it. Takes a moment because it's got to do a little bit of thinking, but there we go. There it's run the graphics, and I can click back and forth on the plots. I notice there's a little X. If I want to, I can delete that. Now I'm down to one tab. I can delete that. Now I've got an empty window. That might be useful if I've got an ongoing program that keeps putting stuff up. If you don't want that behavior, there's an option on there, disable delete, and then it doesn't give you those little tabs. It doesn't allow you to delete the tabs. If you just simply run the file rather than import it, it's going to run all that extra code at the end of the module. So let's do that. And now it's going to do a little bit more stuff. Okay, so the first thing it does is define a window that's too big for me to deal with two different tabs. And you'll see here it says press any key inside plot. So if I do that, make sure I'm inside I've got this live. I believe, yeah, over here on the console screen, it tells me that I pressed the A key and it tells me what the coordinates were, where I press the A key. So if you want to write code where you're going to interact with your plot, that gives you a demonstration of how you can do it. It knows the difference between a shifted S and a regular S. This one, I have given you some example of, I put some buttons on here. And you'll see, so up here I've put some text. And you can't see it down below, but there's a little bit of text down below here. What I didn't show you was stuff that you get from Matplotlib automatically. Bad thinking. Okay, this button here, if you click on that, sorry, yeah, you can move the plot around. Okay. If you have a multi-button mouse, let's see, how do I do this? I've got to remember. There we go. Yeah, no, let's see. That's it's been a while since I've done this without a, well, with a multi-button mouse you can also zoom in and zoom out with this, which I'm not being able to do, but I know I can. Yeah, there it goes. Okay. So I'm using shift and control, and you can see now I'm zooming in on it or zooming out by dragging it, by moving the mouse up, so on. And if I don't like what I'm seeing, I can go back by pressing on the little house icon. Okay, there's a stack of stuff, and I can go through them. So that brings me back to the home. The icon that's over here, that's partly obscured for reasons I'm not completely sure why, allows me to draw a box, and that's my zoom. And again, I can go back. I can save whatever I'm seeing, and I have a bunch of different formats I can save it as. Okay. I can define buttons. So here's a button, and the button does something. It's going to plot something, calculate and plot something completely different. And again, these buttons down here still work. I can zoom in if I want to. And yes? Can I change? If I had written my code to do something, if I could implement a button that would say, for example, remap the color map onto a different portion or something like that. Is that what you're saying? Or I could tell it, define it that it would go, pressing a different key or pressing buttons would cause it to use different color maps. I haven't implemented anything like that, but you can absolutely do that. Yes. In this case, I deleted the old data and I calculated new data. What's that? But I just give, I'm reusing, actually I don't remember, I may be deleting the old plot tab or reusing it, I'm not sure which. But I am reusing the window for sure. Okay. And when I do it a second time, you'll see I got a quit button. So that actually allows me out of this routine. So there's a lot of stuff here that you're not ready to use because we haven't talked about how to write buttons and stuff like that. But I wanted to at least show you how one can take a module, stick some code into it, and when you're done, you have a nice demonstration for how to use that code. Yeah. So when you so first of all, the question was, suppose that I've done some very complicated calculation, takes an hour to get to that result. What do I do with it? Well, first thing you probably want to do is save it in a file so that you can reload it later. You can do various things. You create a plot object It usually is very, very fast to create the plot, so there's no problem in deleting the plot and replotting it again. But if it is, you may want to, you can manipulate the plot. But how you deal with things at that point is really up to your level of sophistication. If all you want to do is to write your output, plot it, maybe create a hard copy PNG or PostScript or something like that copy of your stuff, then that's pretty straightforward. If what you want to do is manipulate it in ways that you know ahead of time what you're going to want to do, depending on what the data look like, then you'll probably want to do that by setting up buttons and things like that that will help, or keystrokes or something like that that will say, okay, for this result I really want to see it in grayscale, but this other result I really would prefer to see it in color. Another possibility, though, is if you really don't know what you want to do with it, you might want to do this by doing the calculation first, saving the results. I mentioned Pickle. That's a nice way to do that. Then you go into IPython. You read your results back in, and now you can type in all the various plotting functions and plot it until you come up with a way that you really like it. And then once you come up with a way you really like it, you save the commands that you used to get there, and you can stick them into your script later.